Okay, on number 11, it says determine the intervals on which the function is increasing, decreasing, and constant. And when we were talking about this problem, we kind of said, okay, well, you need to go from the left to the right of your graph. And if you go from the left, it looks like it's going down first. So this part would be decreasing. Then it kind of levels off. So this part from here to here is constant. And then we have this last section that's going back up. So this would be increasing. And what you have to do is you have to compare this to what's going on with your x-axis. So this is my x-axis. So down here, I would be going to negative infinity. If I go this way, I'm going to positive infinity. And we said this first part, we're going down, so we would be decreasing. And we're decreasing from negative infinity until, looks to me like we're at about -4. That's where we're decreasing. And then in this middle part where we're just staying the same, we're constant. We're constant from -4 to where x is +4. And then it looks like we're going up. So we're increasing on this section right here. And you always want to go from left to right. You want to make sure you do that. But this, you're increasing from 4 to infinity. And so on number 11, the right answer is going to be C. Okay. So on number 12, it says, how can the graph of f of x equals negative parentheses x minus 3, close the parentheses squared, plus 10 be obtained from the graph of y equals x squared? This negative in front is going to be a reflection across the x-axis. Okay. Then you've got this -3 in here. And when it's inside the parentheses, it's opposite of what we think. And so instead of shifting it to the left 3, we're going to go right 3. And then the plus 10 is exactly what we think. So we're going to go up 10. And that's going to be C on this answer. Okay. And once again, I just want to remind you guys that you can use your final to replace one of your low test grades. So if you missed a test or you just, I always had trouble in classes on test number 1, just because I was trying to figure out what the teacher was doing at that point and what I needed to study. So this will replace your one of your lowest test grades, and it will help your grade pretty significantly when you do that. So number 13, it says find the zeros of the function. So to find the zeros, we want to find the answers. You can do this 2 ways. You can use your polyroot finder here. I'm noticing that a lot of these answers have I's in them. So that kind of makes me think we're going to have to use the quadratic equation or quadratic formula here to do this problem. So the quadratic formula says to find x, you're going to do negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So in this problem, a would be the number in front of x squared, so it would be 1. B would be -4, and c would be 13. So we're just plugging this stuff in. So negative b is the first thing that we come to, and b is -4 plus or minus the square root b squared. So when I plug something in, I always put it in parentheses. Pardon me. It just helps me get the right answer. So times -4 times a times c. Well, our a is 1 and our c is 13. All over 2 times a, and a was just 1. I would strongly encourage you to kind of take this step by step. Don't try to type all this in your calculator at one time. Just do -4. Well, that's a +4. Then we've got plus or minus. You could figure out this part underneath the square root sign in your calculator if you want to. It's going to be 16 minus 4 times 13. That's what we're going to end up with there. So you could just type that part in your calculator. And I'm getting negative 36 here. Okay, and then over 2. And I'm going to erase this part because it's way too big. So square root. So you need to remember on this problem that the square root of -1 is equal to I. That's important. So we're going to end up with 4 plus or minus, well, the square root of 36 is just 6. But then I've got this negative that I need to take care of, which is going to get me the I part of this over 2. And then finally, I'm going to just write myself a note. I'm going to divide, 2 can go into every one of these things. So divide everything by 2. 2 will go into 4, 2 will go into 6, and 2 will go into 2. So when I do that, I'm going to end up with 2. 4 divided by 2 is 2, plus or minus 6 divided by 2 is 3. And then when I do 2 divided by 2 on the bottom, I end up with nothing. So this would be my final answer here on number 13, which ends up being C. I use the quadratic formula on that. Okay, number 14. Find the vertex of the parabola. Find the vertex of the parabola -3x squared minus 24x minus 54. Okay, there's a formula to find the vertex. I like using that formula. The calculator can also help you find the vertex, but if you're not really good at messing with your windows, and I don't mind whichever way you want to do it, it's fine. I'm going to show you how to use your calculator. I'm going to show you how to do it by hand just because it always works. And if you use your calculator, it always works as well as long as you know how to adjust your windows. But, and we can go look at both things. But on this problem, I would say x is equal to -b over 2a. That's the x point on the vertex. Well, a here is -3, b is -24, and c is -54. So if I want to find the x coordinate of my vertex, all I have to do is say -24, because that was my b, over 2 times a, which is 3. And so I get 24 over 6, which ends up being 4. So you can probably tell the right answer right now because there's only one x that is a 4 on this problem. Back up here. Hold on, I've done something here. 4 over 2a. Oh, let's see what I did now. When I plugged in my a is not just 3. I wasn't paying close enough attention. It's a -3. We need to put that negative there, which is going to change this to be a -6. Okay, I need to slow down a bit. So when I plugged in a is a -3, not +3. Make sure you go back and fix that. And then 24 divided by -6 is going to be -4. So I already know that my answer is D here. I want to go ahead and try it out though, and make sure that whenever I plug in to my equation, I say, well, what is f of -4? -3 times -4 squared minus 24. All I'm doing is plugging in my -4 to get my answer. And when I do that, the answer is -6, which is another reason why I know that this is correct. Okay. I'm going to just for note's sake, and let's go and look at how you would do this on the graphing calculator, just to remind you guys. Let me make sure, let's see. Don't see my graphing calculator as an option here right now. Let me go. That. Okay, so when I go to my graphing calculator to work this problem, I am just messing this up today. And I just type in my -3 and then x squared minus 24x minus 54. Okay, and then I'm just going to look at the graph. I'm going to eyeball it. I can tell that my vertex should be way down here. So it is on my screen. So that's nice. Then when I go to find it, I want to do second calc. And I want to, that was definitely a maximum because it never got any higher than that. So I'd hit enter here. And I want to pick something to the left and something to the right, but I don't even see my cursor here. It's telling me my cursor is at 0, which would be way over here. So I need to use my arrows and kind of arrow back and get to that place where I can see my cursor. So there it is. Now it's to the left of my maximum. I'm going to hit enter. I'm going to go across and over, and I'm going to hit enter again. And then I do want it to guess. And it's telling me that it's -3.99999, which is my -4. And then y is equal to -6. So it did give me the answer. I could verify it there if I wanted to. Again, on this problem, I really like to just do it by hand. But you can tell that I made a mistake. So when I accidentally plugged in 3 instead of -3. So the calculator would have helped me catch that. So it might be good that you know how to do it both ways and that you can check. So number 15, find the zeros of the polynomial function and state the multiplicity of each. Okay, so on this problem, I go ahead and just separate this thing out. So it's 2 times x plus 6. And that part squared. And then I've got an x minus 6 cubed. Okay, there is no x in this 2 part, so there's nothing to do here. If it said 2x, I would need to solve that for 0. But if there's no x, you're not going to mess with it. Then I would say, well, when is x plus 6 equal to 0? And we've learned in this class that it's always going to be the opposite. So if it's a +6, it's going to be -6. And this 2 means it has a multiplicity of 2. When I solve this part, x minus 6 is equal to 0, not 3. I'm going to add 6. And once again, we're getting the opposite of what we had. So if we have a -6, we're going to get a +6 here. And then this 3 tells us our multiplicity. So we have a multiplicity of 3 here on 6. So number 15 is going to be B. So -6 with a multiplicity of 2, which is what we said, and 6 with a multiplicity of 3. On number 16, they're asking you, let me go back so you can see both problems, but they're asking me to graph this function. Okay, there's a lot of things that I need to consider here. One of the things that I'm looking at is this is not a terrible calculator problem, and I'm going to show you how to do this on the calculator. But you're going to have to change your windows if you want it to match this. So here's what I'm noticing on this problem. Let me blow up my screen just a little bit. So what I'm noticing on this problem is that when I go to my calculator, I'm going to need to make it from -6 to +6 on the x-axis, and from -240 to +240 on my y-axis. So the other thing that I'm noticing is that when I just look at this thing, we've got 3 parts that we can kind of look at. Okay, -x, when is that equal to 0? Well, has to be equal to 0 when x is equal to 0. So when I go through here and I look at my coordinates and I look at this, it looks like, so I may or may tell from that, it kind of looks like each one of these, this one, it looks like it might be a little bit off, but it's hard to see on this graph. If you look at x equals 0 on each of these, it looks like it goes right through the middle of that. Okay. Another thing I could do is I can solve this and say, well, when is x plus 4 equal to 0? Because this intercept didn't really help me. So I'm going to look at x equals -4. And remember that if you have an even multiplicity, that it means it's going to bounce right there. It's not going to cross, it's going to bounce at -4. So I'm kind of eyeballing this graph, and it does look like this one bounces at -4. 1, 2, 3. This one is -3 and not -4. So I do not think it is B. If we go here, 1, 2, 3, 4, it does look like it's bouncing at -4. I go here, 1, 2, this one looks like 3. So I do not think that this is it. Okay, I'm going to solve this last x minus 3 equals 0. So when I do this problem or do this part of the problem, I'm going to add 3. And so we get x is equal to 3. And so on this part, it also is a 2. So it's supposed to bounce here, not cross over the x-axis. It's just supposed to be tangent. So it bounces and goes back at 3. So I'm going to go here and go 1, 2, 3. That does look like that's happening there. And then this one is 1, 2, 3. It does look like it's happening there. So that didn't really help me. I do have it narrowed down to A or C. Another thing, if you're not good with the graphing calculator, is you could pick another point. So you could pick something bigger than 3, like 4, because on 4, this one's going to be positive. So when x is 4, this one's positive and this one's negative. You could do that. I'm going to go to my calculator now to kind of show you what I would do to my windows to change this to make it match. So I'm going to go to my window and I'm going to make it match what our graph said. So on this one, it said that we had an x minimum. Our graph went from -6 and we had an x maximum of +6. And then on our y-axis, we had a minimum of -240. And we had a maximum of +240. Okay, I'm going to go to my y equals. I'm going to type in my function that we had here. So x plus 6. And we're squaring that. And then x minus 6. Also squaring that. Okay. And then I'm going to look at my graph. And so let me make sure. And I typed in 6, I think, instead of what I needed to type in. I was typing in the problem above. I am so sorry. So I need to do x plus 4 when I'm typing in, and I need to do x minus 3. No, it always helps when you actually type a problem incorrectly. So let's look at that. So here's our problem. I can tell that this is going down after this point. So I think that we're going to pick C for our right answer. I also can go to my table and I can go, what happens to 4? 4 is -256. So it's going down after what we had. So when I go back here and I look at this, you can notice that after 4, it's going down. That's the one that matches the closest C. Okay. One that matches close to that one is C. Find the vertical asymptotes of the graph of the function. Okay, vertical asymptotes. Remember that when you're looking for vertical asymptotes, you're worried about Well, first you're worried about if there's any holes. Okay, so that's important. So if you have a hole, that's not going to be a vertical asymptote. And a hole happens when something cancels out on the top and the bottom of your fraction. You're also, after you figure out if you have any holes, you're going to figure out where are there problems in the domain. So when is the bottom of the fraction going to equal 0? So when I'm looking at this, I'm factoring the top part of my fraction, or the numerator, factoring the numerator. So I'm saying, what multiplies to -10 and adds to 3? Well, that would be x plus 5 and x minus 2. 5 times -2 is -10. 5 plus -2 is 3. Remember that you can use your graphing calculator to figure out the roots and then go backwards here and plug it in. Because the calculator would give you the points -5 and +2, and then you would just go backwards and put those in there. What multiplies to -8 and adds to -2? So we would say x minus 4 times x plus 2. -4 times 2 is -8, but -4 plus 2 is -2. So on this one, there's not anything the same on the top and the bottom. So there are no holes. So no holes here. So then at that point, you're worried about, well, what makes the denominator equal to 0? So when is x minus 4 equal to 0? And when is x plus 2 equal to 0? And we know that those are going to be the opposites. So we would add 4. We get x is 4. We have a problem. And we would subtract 2 from both sides of our equal sign. And we've got a problem at x equals -2. And so on number 17, we're going to say D. Those are our problems. Those are our vertical asymptotes. Okay. It's been a while since we've worked one of these. This is back in the very beginning. It's asking me to find this composition of functions. So it's wanting me to find G, and I like to write it this way, of f of x. And it's saying that my x is -6. So the first thing I do is work on the inside, and then I'll go outwards from that. So if I want to find f So if I want to do f of -6, then what I'm going to do is everywhere I see an x, I'm plugging in my -6 here. So I work on from the inside outwards. I figure out what the answer to this is. -2 times -6 would be 12, and 12 minus 6 is 6. So f of -6 is equal to 6. Next thing I'm going to do is go to the G part of this. I'm working outwards. So G, now keep in mind that we know what f of -6 is. F of -6 is 6. So we're plugging that in to G. So G is -7. We're plugging in 6 wherever we see an x. Okay. -7 times 6 squared plus 9 times 6 plus 4. So -194 is our answer there. So you'll always want to work on, you want to do your inside first, figure out what the answer to that is after you plug that in, and then move to your outside and plug the answer you got into that. Here's another one of those. This time it's saying find G of f of x. Okay, and we're using the same f of x and g of x as we had up here. So I start on the inside. F of x is equal to negative 2x minus 6. There was no number to plug in this time. We're not using this up here, sorry. My brain is not working today. We are using this right here. That's g of x. So we want to start with f of x because it's on the inside of our parentheses. And there's no number to plug in, so I'm simply writing down 4x squared plus 3x plus 6 because that's f of x. Then it's saying that it wants me to take that. I'm moving this down, and this is what I'm going to plug in to g. This whole thing I'm plugging into g. So here's my g. So when we do this, we would get 3. And we need a very big blank there because inside that blank is supposed to be 4x squared plus 3x plus 6. And then we can put our minus 7. So all I've done is written down g, and wherever I see an x, I'm going to leave that blank. And I plug in my f inside of that x. So the last thing that we want to do is kind of simplify this. So we want to multiply 3 times 4, 12x squared, 3 times 3x, 9x, 3 times 6, 18 minus 7. So it looks to me like I can combine these two. So 12x squared plus 9x plus 11. And so on number 19, we're going to say D. Simplify that after we plug that stuff in, and that's what we're going to get. Okay. On number 20, it's asking us to find the inverse. And we had some steps that we use to find the inverse. Okay. And they ask us first to determine if this is 1-to-1. If it's not 1-to-1, then there's no point in finding the inverse. And for it to be 1-to-1, it has to pass the horizontal line test. So the first thing you may want to do is go to your graphing calculator and just make sure that this thing would pass the horizontal line test. If you graphed it, it wouldn't cross over. If we drew a horizontal line, not a vertical line, it wouldn't cross over it more than once. So it looks like it's just the graph of a straight line. I'm going to go back to my window because we messed with it earlier and change it back to -10 and +10 here, just so we can really get a better picture, because right now it's pretty distorted because of how large I had my y-axis from -240 to +240. So here's what my graph looks like. If I draw a horizontal line through here anywhere, it's only going to hit it one time. So we should be able to find, so it is 1-to-1, and we are able, if it's 1-to-1, we are able to find an inverse. Okay. So the steps to find an inverse. Step number 1 was to make f of x say y. So we're just going to say y equals 3x minus 8. Let's make your f of x say y. Step number 2, switch your x and your y. So wherever you see a y, you're going to put x, and wherever you see an x, you're going to put y. Step number 3, solve. I don't know why that one got a circle. Give the rest of them a circle. Solve for y. So we want to get it to say y equals, we're going to add 8. So x plus 8 is equal to 3y. Divide everything by 3. And these 3's would cancel out, and we would get, okay, y is equal to x plus 8 over 3. I just like to write the y in front better. Step number 4, change your y to f inverse of x. And you get f inverse of x is equal to x plus 8 over 3. Okay, and so on number 20, the right answer is A. There's the steps of how to do that. Okay, there are 5 problems. We've got 5 problems left. There are 25 problems on the test. So we are getting there. If you would type in the chat, if you need me to go back and see one of those problems, we can do that. Or if you have any questions, feel free to ask. Here's a graphing problem. It just says graph this function 2 to the x minus 3. I'm going to let you type the answer to this one in the chat. 2 to the x minus 3. And then I'll go to my graphing calculator and show you that one. 2 to the x minus 3. That was a pretty easy one to be able to just graph. Now on the, I mean, you can, I don't think you need to change it because -10 to +10 should be okay. But you can see that it's going from -6 to +6 on the x-axis and -6 to +6 on your y-axis as well. So let me know if you think that that is gonna, which multiple choice answer you think that's gonna be. I am seeing some A's here. So when I go to my graphing calculator and I've typed in 2 to the x minus 3 and I hit graph. So I'm definitely going to agree with you all that I think that the right answer is A. That would be the graph that is matching the best, A. Okay. Okay, here we go from the logarithm problems. Number 22 says convert this to a logarithm. So remember that if you've got this written, if with the exponent first, all you have to do is say, start with your, so it would be log base 3. Then you skip over the 2, go to the 9, and come back to it. Come back to your 2 is equal to 2. So the log base 3 of 9 is equal to 2. On number 22, that's going to be D. It's backwards, but it's the same thing here. Okay. On number 23, it says to express this in terms of sums and differences. So you can tell that we've got a multiplication here, and then we've got another multiplication on the bottom, because when we multiply, these exponents are multiplied, so that's the same thing as addition. I'm going to work this just a little bit different than I worked in class. I'm just going to see if, because I kind of think this might make a little bit more sense to people. Let me clear this off. So the multiplication went with the, we know we're supposed to add. The properties of exponents say if you've got a multiplication, you would add. So log base b of m to the 6 plus log base b, or p b of p to the 4th. That's what we'd have on the top. And on the bottom, we would have log base b of n to the 3rd plus the log base b of b to the 9th. We also know that we can bring down our exponents in the front and say 6 times the log base b of m plus, bring this exponent down front. So plus 4 log base b of p over 3 log base b of n plus 9 log base b of b. Remember that if you have a log base a of a, that's just 1 if these two things are the same. So that happens here. We've got a b and a b. They're both the same. So that's just going to turn into 9 times 1 right there. Another thing we need to deal with is this division. So we would have 6 log base b. I wrote that b too big because it's supposed to be that little subscript down there of m plus 4 times a log base b of p. Now we've got a division, which means we have to subtract everything on the bottom. So subtract your log base b of n and also subtract your 9 times your log base b of b. Well, this we just said, because these are both b's, this is just 1. So your right answer should be 6 times the log base b of m plus 4 times your log base b of p minus 3 times your log base b of n minus 9 times 1, which is just 9. And so you're going to end up with the right answer on 23 being B. Okay, going to be B. I think the most difficult part of this problem is remembering that you have to, I don't know what you need to do to make sure you remember that when you're dividing, you have to subtract off both of these. You have whatever's on the bottom has to get subtracted off. That's the most difficult part, because you can see that there's an answer there where you would add the 9, because they're going to try to trick you like that. You need to make sure that you go ahead and subtract that off. Okay. This is kind of hard to see, but this D is a division sign, so that one's not right. And so that right answer had to be B. And on our letter A, they just didn't go far enough there, really, for that to solve the problem. Okay, number 24. The number of books, or last two problems. The number of books in a small library increases according to this function. Here we've got this pretty function here. T is measured in years. It says how many books will the library have after 10 years. So basically on this problem, it's got 8,500 times e to the 0.03, and you're supposed to plug in 10 because it's after 10 years. Plugging in 10 for t. I'm going to work this on the calculator just because this is the review, and some of you may not remember how to type the E in your calculator. So let me go there real quick and just do that. So 8,500, and then to get the E, you're doing second ln, and it was to the 0.03 times 10. Get E, it was second ln 0.03 times 10. I'm just going to hit enter, or yes, enter, and it's telling me 11,473.79, and so we're going to round up to 11,474, which is going to be answer C. Okay, last problem. It says to solve the exponential equation. Okay, and so this one is written 2 to the 10 minus 2x equals 4. It would be really nice if I could say get 4 to be 2 to the something, and we can. 4 is, I'm just thinking 4 is 2 times 2, so 4 is equal to 2 squared. So I'm going to replace that. Instead of 4, I'm writing 2 squared, which means that these two have to be equal to each other. So 10 minus 2x is equal to 2. Subtract 10. So -8. Divide by -2. X is equal to 4. So the right answer on 25 is A. So that's it. That's the test review. That's your final review. Your final. So any questions? Well, first off, any questions about anything here?